Okay, so for literally years now, there's been conjecture about the technical makeup of the processor, the T239 processor in the Nintendo Switch 2 hybrid console. Is it 8 nanometer? Is it 4 nanometer? What's going on here? Well, I think for a while we've kind of understood that it's an 8 nanometer part owing to the sheer size of the chip. The motherboard leak was some months ago now. But it turns out that boards have actually seemingly arrived at Chinese retail for people to buy. And from there, we've actually got not one, but two very impressive, very detailed analysis of the chip. And what can I say? Colonel and Geeker1, they did some fantastic work here in showing us what this chip actually is. I think at the end of the day, there's few surprises there, a few wrinkles in the narrative, so to speak. But Oliver, keen to hear your opinion on this.
Yeah, so basically Geeker1 is the main video here, and Geeker1 is a very special, very good Chinese YouTube channel who mostly posts in, I believe, in Mandarin. So not too much English uploading from that channel, but when they do post English upload, it's always an exciting time. They basically bought it from the equivalent of Chinese eBay for $150, the board there. And it's a T239 chip on the die, as previously rumored. It's 207 millimeters squared. They actually measured it out exactly there. So that's very much in line with prior estimates based on just simple photography and looking at different chips in the motherboard and making computations based on that. But the interesting aspect of it is they don't even think, based off of their analysis, they don't think that it is just flat out Samsung 8N, which is the process used for the NVIDIA graphics architectures, or rather for Ampere, the NVIDIA graphics architecture. They think it's actually possibly a hybrid of Samsung 10N nanometers and Samsung 8N. It's a process that has some pitches that are more associated with Samsung's 10 nanometer process, basically, than their 8 nanometer process. But it's important to realize that with the 8 nanometer process, that is more effectively understood as like a customized Samsung 10 nanometer process. Indeed, when I first heard of the process, that's how it was introduced to me, as an NVIDIA customized version of the Samsung 10 nanometer process. So I think that's not too meaningful there, that particular difference. I'd really think much more about the pitches between the various features in the die and the overall logic density. So, at a density like 3 nanometers, you're looking at about 4 times the logic density relative to a process like 8 nanometers, or relative to a process like 10 nanometers, even, because they have almost identical density. So that's really the key thing here. And of course, they make up for it in part by making the die extremely large. Then they go over, there are various details here that are probably familiar to a lot of viewers. They go over the GPU, which has 1536 CUDA cores. No surprises there. There's memory that's rated for 8,533 megahertz from SK Hynix, 12 gigabytes of memory, which is interesting because the device ships at a lower frequency, but of course, this could just be for various sourcing reasons and needing to, bring it down for memory controller reasons. Possibly there are a lot of reasons why they could go with a notionally higher frequency and decrease the frequency. Indeed, that's what they did, I believe, with the Switch OLED and possibly the prior Switch revision, the AmeriCore revision as well. I think they may have sourced in some cases some faster RAM modules, and they actually shipped that there as well. So that's a common feature. And then they ended up doing some performance simulations, and those I thought were kind of interesting here. But I would caution against a couple things with these Geeker1 tests. I think they're very good, but I would caution against a few things. First of all, they projected out performance just using Steel Nomad Lite, for instance, which is a test that either uses DX12 or Vulkan. And the simulated PS4 results don't make a lot of sense there. So they're using a 7870, which is quite an old card. I don't know if that factors into it at all, but they've decreased the clock rates in that card. And it should be outperforming in this chart the Steam Deck by a good margin, you'd presume, given that it's generally much more capable in software than a Steam Deck, right? Considerably more capable in software than a Steam Deck. But it's underperforming it, according to this benchmark, by a good 20%, 15%, which is not really what you normally expect to see. That's one concern. And then on the CPU front, one concern is that these tests they're doing with different kinds of desktop PC parts, they aren't factoring in memory contention issues that could emerge between the CPU and GPU in actual game workloads. They're just running, Geekbench, and they're just running games in an environment where there's no contention issues. That's important to consider on a device like the Switch 2. You are going to end up with some memory contention issues. Also, keep in mind that on Switch 2, you might have certain system resources that are reserved by the system, as is common with other console platforms. And that could potentially eat into some margin of performance, because obviously in a console platform, you don't want to have background tasks eating into main system performance. On PC, you'd have that flexibility. On a console, you'd want to have some ability to, say, download games without that impacting the performance of your Cyberpunks, of your Marios, of your Mario Karts, right? So that's another factor to consider here when we are looking at these isolated tests. That won't necessarily be all the performance that exposed to the Switch 2 system. So, overall, I think this is like an interesting story. I just think at this point, we know so much about the system. We know so much about its performance. And it's pretty clear kind of in the rough ballpark where it's going to end up. But I'd always say to focus on the games more than the spec sheet and even the simulations here, because the simulations can only tell you so much, and the games are kind of actual real things that are running on real hardware. But yeah, just a few notes about the node and things like that I think are interesting here as well.
Mm-hmm. Alex?
One confirmation of the node to me makes me think that this, at least from the SoC perspective, should be pretty cheap production for Nintendo, given its age and the fact that no one's going to be otherwise producing on it. So Samsung is probably happy and was happy to have a customer. So I'd hope they have gotten a good deal with that. But then the rest of the console's price in perspective is probably coming from other sources, and the fact that Nintendo wants to historically make a good profit on their consoles, so that price is probably locked in from that perspective. I really liked this presentation a lot. I liked someone delidding the CPU and SoC, and actually looking at the size of things in relation to other architectures. I do think, though, Oliver's word of caution regarding the benchmark aspect is pretty important, because especially with that simulated PS4 results, if you take a desktop GPU with a limited amount of memory, the max on that one would have been, at least for the standard model, like the 7850, like 2 gigabytes at most, and any sort of memory. That GPU is lacking drivers since I can't even remember the last time that GPU got drivers. It's been a long time. And that GPU, if there's any sort of scenario where it's going out of VRAM budget, its performance is going to tank. And most benchmarks are not going to be made around GPUs that have 2 gigabytes of memory. So I'd actually really imagine that a PS4's GPU would be a lot higher on that list. CPU, though, is a different question, because that's the one area where I think the Switch 2 is going to be, in some aspects, better than the PS4. But once again, with some caveats, I think, due to the power limitations of the device coming in there. But yeah, really good. I love this video. I would love to talk to this gentleman and this channel. They seem to know what's up.
I've got so many notes about this. Where do we begin? Just quickly on the simulation front, and let's talk about that PS4 GPU benchmark. I've got a GPU on the PC side that's very, very close to the PS4 GPU. It's a Radeon R7 270X with 4 gigs of RAM. So it's got more compute units than the 7850. But you need to downclock it to sort of get sort of similar to PS4 GPU performance. I can tell you, in the year of our Lord 2025, if you ran like a PS4 game on it, you would get nowhere near the same level of performance as a PS4. And that's simply because, it's a deprecated part at this point. And, drivers are old. Architecture's not really been, it's developers have moved on the PC space, So the concept of game developers working to a fixed specification console is quite different to game developers working on a PC version of a game. So, that's the bottom line there. The PlayStation 4 in real world scenarios where developers are specifically developing for it is going to be delivering a lot more performance. And just take a look at something like Call of Duty Black Ops, the PS4 versions of that. They're nowhere near as good as the PS5 versions. But if you consider that you're looking at hardware that's akin to a Radeon 7850 or 7870, I'd consider that to be actually miraculous, right, to be honest. Similarly, when you look at what some of the first-party studios like Naughty Dog did with The Last of Us Part 2 running on a base PlayStation 4 at 1080p resolution, that's like astonishingly good. And it's going to be similar to Switch with Switch 2 in that developers are going to be directly addressing that hardware with a lightweight, low-level API designed specifically for that hardware. And we've already seen the fruits of that kind of approach in Switch 1. You know, the Tegra X1 is not a good piece of technology, and yet we've had 8 years of fantastic games. So there's been a lot of people sort of getting hung up on the, you know, on the specs and stuff, but ultimately developers work with what they're given, and they optimize for best results in a way that you won't really see with PC simulations. Now, obviously, we've done PC simulations to give you some idea of the features and, you know, what you could say that initial ports would probably be quite a similar performance profile, right? Because, you know, developers getting used to the hardware. But, you know, that table there, it's, you know, what can I say? Just go and take a look at some of the best of the Switch 1 games. You know, Luigi's Mansion, what they're doing on a Tegra X1 there is just, you know, phenomenal. Those, you know, Doom Eternal running on a Tegra X1. This is nutty stuff, and they made it happen. Mm-hmm. That's the sort of advantage of having a fixed platform. So, yeah, you know, the simulations are fun, but, you know, as Oliver said, ultimately the games do the talking, right? Mm-hmm. The other things I want to talk about, where should we begin? On the chip, you can see when it was taped out, 2021, and it is now 2025.
My goodness.
So I'm curious about the timelines there. It's clear, I think from my perspective, they could have released the Switch 2 from a hardware perspective much earlier. Bearing in mind, you know, you've got comparisons there of when GA107, the RTX 3050, I think that is, was taped out. It's not, yeah, similar time frame. That came out the year afterwards, and yet here we are, like many years on, 4 years on, and Switch 2 is just about to come out. Why is this? I think ultimately finances. The Switch 1 was doing so incredibly well for such a long period of time. There was no need. Nintendo would have been shooting themselves in the foot to release the Switch 2 earlier. And yet that work was carrying on now. You've got physical evidence that the chip existed in 2021. And obviously, the longer they delay using it, the cheaper it likely becomes to make it. And you know, there was just no need for a Switch successor. Now, the other thing, of course, is all of those rumors of the Switch Pro from back in the day, which I'm convinced is a confusion between the Switch OLED, which did have the OLED screen, obviously, but was just the existing unit, and the initial work on the Switch 2. Obviously, the chip existed for quite some time at this point. There were stories of developers getting Super Switch kits at one point. You know, maybe plans changed. Maybe just Nintendo decided there was no need. But the point is that this is now sort of older technology. It's borne out by the process node. It's borne out by the architecture. But ultimately, it doesn't really matter because, you know, Tegra X1 was an underpowered part. I mean, you know, when we revealed that it was Tegra X1 back in the day, there was the usual reaction to digital foundry content when it's something that people don't want to hear, where, you know, the thing is to discredit what we're saying. It was a Tegra X1. It wasn't AMD. And similar with this, it's just, you know, it's just the reality. That's what it is. It's an 8 nanometer part for the most part, but and it is using Ampere architecture. Let's talk about the architecture actually, because we have seen developer disclosures at this point. It in no way refers to the GPU in there as an Ada Lovelace part. Something which did come up in the GeekerWAN video was physical resemblances to Ada. But there was another video from Kernel, I think it is, where they actually compared the architecture to the T234 and the Jetson Orin Nano, where it looks a lot more similar to that. Now, here's the thing, right? Prior to the release of all of this stuff, we have had leaks from across the years about what T239 actually is. And there are indeed some elements from Ada in it, backports, if you like. It seems to be the case based on those leaks, and bearing in mind that those leaks have been borne out now by developer documentation. I consider those leaks to be on the money. The media block seems to be backported from Ada, which makes sense. But also power gating features from Ada, efficiency enhancements from Ada appear to have been backported, which makes sense, right? Because you need a handheld device running at extremely low clocks on an 8 nanometer process, no less, to be as efficient as possible. So bearing in mind that leak, bearing in mind what's literally written in developer disclosures, it's an Ampere architecture GPU. It's an Ampere architecture GPU. And if you actually look at the performance differences clock for clock between Ada and Ampere, it's not really a huge amount in it. And the reason why Ampere was sort of effortlessly outclassed by Ada is because, well, the clock speeds on Ada are much, much higher, sort of 2.7 gigahertz for the most part. Ampere, sort of like 1.7, 1.8, 1.9. That's a huge gulf in performance terms, in terms of sort of, clocks, not necessarily in terms of instructions per clock. Mm-hmm. So, yeah, that's what I've got to say about that. I just think there it is. We've got the specifications now. They are confirmed. We've got confirmation it's an 8 nanometer chip. But at the same time, we're seeing some really nice stuff from the system, just as we saw with the Tegra X1. So, I'm just going to be waiting to see what the games are actually like, which at the end of the day is what it's all about. So, Nintendo isn't doing best of the best hardware. It kind of hasn't since the GameCube days. The systems that they've produced, Wii U accepted, have been hugely successful. The games have been great. That's ultimately what it's about, right?
Yeah.
Any final thoughts there, Oliver?
Well, I'd also just say that one kind of critical factor with regards to the Switch 2's timing in the market here is that in 2020 and 2021, there was a huge spike in Switch 1 sales. If you look back to Nintendo's earnings reports, and that extended the tail of the device by quite a bit, the tail end of the device quite a bit. That, of course, was because probably primarily because people had to stay at home all day because of COVID. Right. But that probably allowed it to stick around on the market for an extra year or two relative to expectations. Obviously, when they were designing and working on the T239 with NVIDIA, they would not have been factoring in the idea that their console would actually be peaking in sales in like year 4, year 5 of the system's life cycle. That's a little bit unusual. And then, of course, the delay between the tape out and the release date of the final finished device makes more sense, especially considering Nintendo usually uses somewhat deprecated, somewhat older technologies. And Tegra X1 was already, a 2-year-old chip in the market by the time Switch 1 came out. And that, for Nintendo standards, was like a pretty short gap between, the cutting edge of the technology and when Nintendo jumped into the pool there. So, yeah, ultimately, there's a lot of controversy around this kind of stuff, and to me, it just doesn't really land at all because this has been the expectation for a long time. I mean, I even remember Rich bringing up T239 back in like 2022, and this probably being the expectation then, just because it's an Ampere architecture. Why wouldn't it be on 8N or some variant thereof, right? That makes a lot of sense. You don't have to redesign it. You don't have to do anything to it. All the major IP can fit in 8N. Why wouldn't it be 8N or, again, another similar variant process? So to me, it's not a big surprise, but yeah, I mean, to people who are really kind of upset or take issue with the fact that Nintendo is using older technology here, that's just kind of their MO. And like Alex said, they are probably getting a pretty killer deal when they go to Samsung and they say, hey, those production lines for 8 nanometer class technologies that you're about to wind down, don't do it. We'll give you a little bit of money just not to do it, not to wind down those lines, which is super expensive. And we can produce our relatively cheap chip on those processes for years to come.
Yeah.
Yeah, and of course you get a die shrink a few years down the road, which is exactly what happened with Switch 1, which gives you mega battery life and likely sort of cost savings at that point as well. So, that's kind of like, it's business ultimately, and Nintendo is really good at it, and more specifically, really good at doing great games, which is what it's about at the end of the day. Any final things from you, Alex?
I'm just curious about what that porting process is, because Ampere would have not been ported to a smaller process node. right? So
Well, it's the same with Tegra X1, right?
yeah,
I think it was
That
on
went to
7
16 nanometer.
also, but nothing
it was on
smaller than
7. Oh, was that
Yeah,
was that the I was going to say prosumer, but the
The data
it wasn't
center chips were
GeForce.
7 nanometer.
yeah, it wasn't GeForce. Yeah.
Mm-hmm.
Yeah, good point.
Yeah.
But I'm interesting. I'm curious to see what it would be ported to eventually, at all. Yeah.
Probably what's most cost efficient for Nintendo,
Yeah.
which is absolutely fine, right?
Yeah.
Okay, lots to go over still with Switch 2. Obviously, when we get units, who knows when that's actually going to happen? But we've got our pre-orders in, and we're hugely excited about just getting to grips with a new system there, an NVIDIA-based console, no less, which is using modern features. I think that's the other thing, of course. It's no real problem with Ampere as such. It's got the features that are needed for a current generation console. It's
Right.
got ray tracing, it's got machine learning.